The Pleistocene epoch, a time of giants and formidable predators. Amongst them, the saber-toothed cats reigned supreme, instantly recognizable by their fearsome, elongated upper canines. These iconic predators have captivated our imaginations for centuries. But what if I told you that the story of the saber-toothed cat is even more fascinating than we first thought? New discoveries reveal a surprising twist in the evolutionary tale of these prehistoric hunters, the existence of not one, but two sets of sabers. Join me as we delve into the world of these extraordinary creatures and uncover the secrets behind their double sabers. Prepare to be surprised, for the story of the saber-toothed cat is about to take an unexpected turn. The defining feature of the saber-toothed cat, of course, is their namesake, the sabers. These elongated upper canines, some exceeding 20 centimeters in length, were truly a sight to behold. Imagine, if you will, a predator approaching its prey, its mouth agape, revealing these formidable daggers. But these sabers were not simply for show. They were precision instruments designed for a very specific purpose. Unlike the crushing bite of a lion or a tiger, the saber-toothed cat's bite was all about finesse. Their jaws were adapted to deliver a deep, piercing bite, capable of severing arteries and veins, causing rapid blood loss in their prey. These were not teeth meant for crushing bone. They were delicate weapons, designed to exploit the vulnerabilities of their prey. The shape and size of these sabers varied between species, each adapted to the specific prey they hunted. Some were shorter and stouter, while others were long and slender like scimitars. But one thing remained constant: the saber-toothed cat's reliance on these remarkable teeth for their survival. They were the apex predators of their time, and their sabers were the key to their success. Now, let's turn our attention to a lesser-known aspect of saber-toothed anatomy, their lower jaws. While the upper sabers often capture our imagination with their sheer size and lethality, the lower jaw holds its own secrets and significance. While the upper sabers steal the show, the lower jaw played a crucial, albeit less glamorous, role. It was not just a passive structure but an active participant in the saber-toothed cat's predatory prowess. In some species, the lower jawbones were unusually thick and robust, almost as if they were designed to withstand immense pressure. This robustness wasn't merely for show, it had a functional purpose that was vital for the cat's survival, and in a way they were. These reinforced jaws acted as a counterbalance to the impressive upper sabers, providing the necessary support to prevent the teeth from breaking during a kill. The lower jaw had to be strong enough to absorb the shock and force exerted when the sabers pierced through the tough hide and flesh of their prey. Imagine the force required to drive those long canines into the flesh of a struggling prey animal. The lower jaw had to be more than just a support. It had to be a stabilizing force that ensured the upper sabers could do their job effectively. Without a strong, supportive jaw, the sabers themselves would be at risk of snapping. This would have been catastrophic for the saber-toothed cat, as broken teeth could mean the difference between life and death in the wild. But the story of the lower jaw doesn't end there. It wasn't just about strength and support, it was also about adaptation and evolution. In a surprising twist, some saber-toothed species developed even more peculiar adaptations. These adaptations reveal a fascinating glimpse into the evolutionary pressures and ecological niches these predators occupied. Take, for instance, Thylacosmolus, a saber-toothed predator from South America. This remarkable creature possessed elongated lower jaws that actually sheathed its upper sabers, protecting them when not in use. This adaptation was unique and highlights the diverse evolutionary strategies employed by different species. This remarkable creature possessed elongated lower jaws that actually sheathed its upper sabers, protecting them when not in use. This adaptation was unique and highlights the diverse evolutionary strategies employed by different species. Other lesser-known species show evidence of large, tusk-like lower canines, hinting at a possible double saber arrangement, albeit not as prominent as the uppers. These adaptations suggest that the lower jaw was not just a passive structure, but an active participant in the evolutionary arms race. These adaptations, while less common, suggest a fascinating evolutionary exploration of the saber-toothed design. The lower jaw, often overshadowed by the dramatic upper sabers, played a vital role in the survival and success of these iconic predators. Chapter 3. But what was the purpose of these double sabers? These elongated canines have fascinated scientists and enthusiasts alike for generations. How did they function in the life of these prehistoric predators? Were they purely for show, or did they serve a more practical purpose in the daily survival of these magnificent creatures? The answer, it seems, lies in the biomechanics of their bite. By studying the structure and wear patterns on fossilized teeth, scientists have begun to piece together the puzzle. Imagine a saber-toothed cat, teeth bared, sinking its upper canines deep into the flesh of its prey. The sheer force and precision required for such a bite is astounding. Now picture the lower jaw coming into play, those elongated canines acting like hooks, securing the animal in a vice-like grip. This intricate mechanism allowed the predator to maintain a firm hold on its struggling prey. This dual saber system may have provided these predators with unparalleled control over their prey, preventing escape and ensuring a swift, efficient kill. The combination of upper and lower sabers worked in harmony to maximize the effectiveness of each bite. The lower sabers, in essence, amplified the effectiveness of the upper sabers, making them even more deadly. They acted as a secondary line of defense, ensuring that once the prey was caught, it had little chance of breaking free. Furthermore, the presence of lower sabers could have helped to distribute the stress of the bite, reducing the risk of damage to the delicate upper canines. This distribution of force was crucial for the longevity and effectiveness of their primary hunting tools. This was particularly important for species that preyed on large, powerful animals, where a struggle could prove fatal if a saber were to snap. The ability to handle such formidable prey without damaging their own weapons was a significant evolutionary advantage. Some scientists even speculate that certain species may have used their double sabers to grip slippery prey, such as large fish or aquatic mammals. This adaptability would have allowed them to exploit a variety of food sources in different environments. The possibilities are intriguing, and further research promises to reveal even more about the hunting techniques of these fascinating creatures. As we continue to uncover more fossils and develop new technologies, our understanding of the saber-toothed cat's biomechanics and function will only deepen, shedding light on one of the most iconic predators of the prehistoric world. Chapter 4. Now it's important to remember that the term saber-toothed doesn't refer to a single monolithic group of animals. Instead, it encompasses a variety of species that independently evolved similar traits. This fascinating phenomenon is known as convergent evolution. In fact, the saber-toothed morphology evolved independently in various lineages throughout prehistory. This means that different groups of animals, separated by millions of years and vast distances, developed similar adaptations to thrive in their respective environments. Take, for instance, the true saber-toothed cats like Smilodon. These iconic predators roamed the Americas during the Pleistocene epoch and are perhaps the most well-known of the saber-toothed animals. These iconic predators possessed the classic combination of elongated upper canines and robust lower jaws, but lacked any significant lower saber-like projections. Their powerful build and specialized teeth made them formidable hunters, capable of taking down large prey. Then we have the metatherians, such as Thylacosmilus. These creatures lived in South America and, despite not being closely related to cats, evolved a remarkably similar saber-toothed appearance. These South American predators, though not closely related to cats, evolved a remarkably similar saber-toothed appearance. Their unique adaptations allowed them to fill a similar ecological niche in their environment. However, their lower jaws with their sheathing adaptations set them apart. Unlike the true saber-toothed cats, Thylacosmilus had lower jaws that formed protective sheaths for their elongated upper canines, a unique adaptation among saber-toothed predators. And let's not forget the nimrabids, like Hoplophonius. These predators lived during the late Eocene to early Miocene epochs, and are often referred to as false saber-toothed cats. These extinct feliforms, while possessing smaller sabers than their Smilodon counterparts, show evidence of potential double saber arrangements, with elongated lower canines adding to their predatory arsenal. This unique feature may have given them an edge in capturing and subduing prey. Even further afield, we find the barbarophilids, such as Barbarophilus. These predators lived during the Miocene epoch and, while not true saber-toothed cats, had their own impressive adaptations. These powerful predators, while not technically possessing sabers in the strictest sense, had robust lower jaws and heavily muscled necks, suggesting a bite force capable of taking down large prey. Their adaptations made them formidable hunters in their own right. This incredible diversity among saber-toothed predators highlights a crucial point. The saber-toothed condition is a functional description, not a strict evolutionary category. It encompasses a wide range of species that developed similar traits independently. It's a testament to the power of convergent evolution, where similar environmental pressures lead to the development of similar adaptations in unrelated species. This process has given rise to a fascinating array of saber-toothed predators throughout history. The world of saber-toothed predators was a diverse and fascinating one, with each species showcasing its own unique take on the saber-toothed design. From the true saber-toothed cats to the Metatherians and Nimravids, each group of predators adapted to their environment in remarkable ways, leaving behind a rich legacy for us to study and admire. Would you like a diagram comparing the jaw anatomy of Smilodon, Thylacosmolus, and Hoplophonius? The evolution of double sabers in some saber-toothed predators is a testament to the ingenuity and adaptability of life on Earth. These remarkable adaptations, whether for reinforcing a powerful bite, providing a protective sheath, or enhancing prey restraint, showcase the incredible diversity of life that once thrived on our planet. The study of these extinct predators continues to challenge our understanding of prehistoric ecosystems and the remarkable ways in which animals adapt to their environment. The story of the double sabers is a reminder that there is always more to discover, more to learn about the incredible history of life on Earth. If you enjoyed this glimpse into the world of saber-toothed cats and their double sabers, be sure to like this video, leave a comment below, and subscribe to the channel for more fascinating prehistoric insights. Until next time, keep exploring the wonders of the natural world.